So in this video, I'm going to go over the rest of the problems that we didn't get to finish in today's class. So let's look at this question from the EOC. It says to multiply h squared plus 9h minus 1 times negative 4h plus 3. So remember, we can do this many ways. One way is using the box method. So we have 3 terms by 2 terms. So I'm going to draw 3 and 2. And so here I'm going to put h squared, 9h, and 1, and negative 4h and 3. So now in the upper left-hand side, I have h squared times negative 4h. So I can pull out my coefficient, which is negative 4. And then I have h squared times h. Remember, this is an h to the 1, so that's going to be h to the 3. Then I have h squared times 3. So if I pull the 3 in front, I have 3h squared. Next box, I have 9h times negative 4h. So I pull out the 9 and the negative 4, which gives me negative 36. And then h times h is h squared. Then the next box over, I have 9h times 3. So 9 times 3 gives me 27. And then I have h. Negative 1 times negative 4h. Negative 1 times negative 4 is 4. And then I have h. And then I have negative 1 times 3, which is negative 3. So remember, my like terms will be on the diagonal. So here I have 2h squared terms. I have 2h terms. And I'm going to go ahead and combine all of these terms. So this gives me negative 4h cubed plus 3h squared minus 36h squared plus 27h plus 4h minus 3. So when I combine those like terms, negative 4h cubed, 3h squared minus 36h squared, so 3 minus 36 is negative 33, so you have negative 33h squared. 2h plus 4h, that's plus 31h, and then you have minus 3. So the correct answer is F. So now let's try this one. So this is 2 trinomials being multiplied together. You can either use the box method or you can distribute. I'm going to do this problem by distributing to show you the other method of doing this. So we have x squared plus x plus 4 times x squared plus 6x minus 1. So I take each term on my first trinomial and distribute it to everything in my second trinomial. So this gives me x squared times x squared plus 6x minus 1 plus x times x squared plus 6x minus 1 plus 4 times x squared plus 6x minus 1. So now I distribute each of these one at a time. So x squared times x squared plus x squared times 6x, and then minus x squared times 1. So then I go to my next terms and I distribute this x. So I have x times x squared plus x times 6x minus x times 1. And I distribute the 4, and that gives me 4 times x squared plus 4 times 6x minus 4 times 1. Okay, so now I'm going to simplify these using the rules of exponents. X squared times x squared is x to the 4th. Here I have x squared times 6x, so that's going to give me 6x cubed, because x squared, and that's an x to the 1. Now I have x squared times 1, so that's minus x squared. X times x squared is x cubed. X times 6x is plus 6x squared. Minus x times 1 is x. Plus 4 times x squared is 4x squared. Plus 4 times 6x is 24x. Minus 4 times 1 is 4. So now remember, I have to finally go through and pull out any like terms. So the x to the 4th is by itself. Then I have 6x cubed. I have x cubed. And that's all my x cubed terms. Then I have minus x squared plus 6x squared and plus 4x squared. And then I have minus x and plus 24x, and finally I have minus 4. So this is x to the fourth plus 6x cubed plus x cubed is 7x cubed plus negative 1x squared plus 6x squared plus 4x squared is plus 9x squared. Negative x plus 24x is plus 23x, and you have minus 4. So the correct answer is answer choice C, and you should get the same result if you use the box method. So now we're going to look at some special patterns. These special patterns are what happen when you multiply binomials that have a particular form. You can use the special patterns, or you can use FOIL or the box method to get the same result. It's a matter of choice. But like I told you, next week, the week after next week, we're going to start doing factoring, which is going backwards from the answer to the original multiplication problem. And that's when these special patterns are going to be used a lot. So it is a good idea to start getting used to the idea of special patterns and how they work. So the first set of special patterns we have are what called perfect square trinomials. So here, this is what happens when you have a binomial multiplied by itself. So a plus b squared is like a plus b times a plus b. So what happens is it follows a pattern where the terms will be a squared plus 2ab plus b squared. There's a similar pattern when you have a minus b squared, which is the same thing as a minus b times a plus b. So let's look at some examples. So use special patterns to multiply x plus 2 squared. So it is perfectly okay if you write this out as x plus 2 times x plus 2, and then if you use the box method or FOIL or any other way to distributing to multiply. Okay, but I'm going to show you how to do this with special patterns. So this has the pattern, since it's an addition problem, this has the pattern a plus b squared. So I know that the result is going to be a squared plus 2ab plus b squared. So what I do is I call this first term, I call that a, and then the second term I call that b. So when I plug it into this formula, so this is x squared plus 2 times x times 2 plus 2 squared. So now I just need to use my exponent rules to simplify this. So x squared plus 2 times 2 is 4, so I have 4x, and then plus 4. And you should get the same answer if you do this doing the box method. You can check that on your own. So let's look at this one. This is 2x minus 3 squared. So since it's a minus, it has the form a minus b squared. So I can expand that out as a squared minus 2ab plus b squared. So in this case, I have 2x minus 3. So I'm going to call this 2xa, and this 3, I'm going to call that b. So when I write this out in the formula, this is going to be 2x squared minus 2 times 2x times 3 plus 3 squared. So remember, when I have something inside of parentheses being squared, that squared goes to both parts on the inside. Okay, so this is not just 2 times x squared. This is 2 squared x squared, which is the same thing as 4x squared. So be careful on that. And the next term, okay, I'm going to pull out the whole number. So I have 2 times 2 times 3, and I have times x. So 2 times 2 is 4, 4 times 3 is 12, so I have minus 12x. And my final term is 3 squared, which is 9. And that is how you use those special patterns. So here are a few more examples. 2x plus 5 squared, so that has the form a plus b squared. So I know that when I expand that out, that's going to be a squared plus 2ab plus b squared. So now I plug into this formula, and I have 2x squared plus 2 times 2x times 5 plus 5 squared. So 2x squared, remember the squared goes to both terms on the inside. So this is 4x squared plus 2 times 5 times x. So this is 2 times 2 is 4, 4 times 5 is 20, so 20x. And my final term is 5 squared, which is 25. So here's another one that's in the form a minus b. So I have a minus b squared, which equals a squared minus 2ab plus b squared. So this gives me 2x squared minus 2 times 2x. In this case, b is 3y, and then plus 3y squared. So remember, whenever I'm squaring one of these terms, I have to distribute the square to both parts on the inside. So this is 2 squared x squared, which is 4x squared. Here, I'm going to pull out all the coefficients. So I have 2 times 3, and then I have an x and a y. So 2 times 2 is 4, 4 times 3 is 12, so I have 12xy. And finally here, the squared goes to both parts, so I have 3 squared y squared, which is the same thing as saying plus 9y squared. So now you can try these two examples on your own. So x minus 3 squared, you're going to use the a minus b formula, and when you do that, you should get answer choice B. 2x minus 6 squared, a is 2x and b is 6. So we have a squared minus 2ab plus b squared. So that's 2x squared minus 2 times 2x times 6 plus 6 squared. So this gives me 4x squared minus 4 times 6 is 24. 24x plus 36, which is answer choice A. So now let's look at another special pattern. So this special pattern is when you multiply what are called conjugate binomials. So conjugate binomials are binomials that look exactly the same, except they have opposite sign. So you see here a minus b times a plus b. So they're the same binomial, but they're opposite in sign. So when you multiply that, you will get a squared minus b squared. The middle term will basically cancel out. So let's look at an example of this. So you see here x minus 2 and x plus 2 are conjugate binomials because they're the same binomial but opposite in sign. So what this tells me is that this is of the form a minus b times a plus b. And my formula tells me that can be written as a squared minus b squared. So in this case, a is x. So this is x squared minus 2 squared because b is 2. X squared minus 2 squared. 2 squared is 4, so this is x squared minus 4. Let's use the box method to check this answer, because I want to show you why the middle terms cancel out. So if I use the box method, I have x minus 2 and x plus 2. So here I have x times x, which is x squared. Here I have x times negative 2, that's negative 2x. Left corner I have 2 times x, which is 2x. And the right corner, I have 2 times negative 2, which is negative 4. So now these are my two like terms that combine. So I have x squared minus 2x plus 2x minus 4. So you see here, these middle terms are equal and opposite, so they will add up to 0. Negative 2 plus 2 is 0. So I have x squared plus 0 minus 4, which is just x squared minus 4. So you see, I get the same answer either way I do this problem. So here's another one. I once again have a plus b times a minus b. So this will be a squared minus b squared. So that's 3x squared minus 1 squared. 3x squared is going to be 3 squared x squared. 1 squared is just 1. 3 squared x squared is 9x squared. So this is 9x squared minus 1. So why don't you try these two problems? X minus 1 times x plus 1. Okay, this is an error. It should be x squared minus 1. That is the correct answer because this is a and this is b. So this will be x squared minus 1 squared, which is x squared minus 1. On this one, you once again have a and b. So this is a squared minus b squared. So it's going to be 2x squared minus 4 squared. 2x squared is 2 squared x squared. 2 squared x squared is 4x squared. Minus 4 squared is 16. So we have 4x squared minus 16, which is choice C.